Okay, this is the third part of Unit 6, Chapter 6, Molecular Symmetry. And this is quite a short section in that we're just going to overview some of the symmetry operations and elements that we've looked at already. So this table summarizes everything quite nicely. We know about identity has the symbol E. Then we know about proper rotation by 360 degrees divided by n, otherwise known as a CN rotation. We know about reflection, which is as a result of a mirror plane, given the symbol sigma. We know about inversion, which where there is a center of inversion has the symbol I. And then lastly, we have improper rotation, where we have rotation by 360 degree divided by n, followed by reflection in a plane perpendicular to the rotation axis. Now there's some important things to note. First of all, in specifically to the improper rotations, if we do the improper rotation and we do an S1, okay, that means that we do a full 360 degree rotation and then we do a reflection. That is the equivalent of a mirror operation. Okay. If we do an S2, which is a improper rotation of 180 degrees followed by a reflection, that is equivalent to an inversion. And then lastly, if we do an S4, which is an improper rotation by 90 degrees followed by reflection, that is equivalent to two twofold rotation operations. Okay, let's have a look at the first one, which is the one at the top here. Okay, that you can see there's a full 360 degree rotation right about here. Okay, and then the reflection across the mirror plane, and we end up with a molecule over here. That shows that it is purely a 360 degree rotation followed by reflection. It's an equivalent of a mirror plane. All right, now let's look at S2. S2 means we do a 180 degree rotation followed by reflection. So if we took the atom, which is over here, and we rotate by 180 degrees like that, okay, then we reflect and it ends up in this position over here. You can see that the equivalent symmetry operator would have been the inversion center, which you can see in the middle over here, represented by the red dot. So that's important to note, the equivalent symmetry operations and elements. Okay. This table that's on the next couple of slides just shows some examples and the symmetry operations and elements that are involved. So with the identity, remember there are no symmetry elements. All the atoms remain unshifted, and the example they've given us there is that tetrahedral, what is that, fluorochlorobromo-methane. A rotation. A twofold rotation is a C2. The symmetry element is obviously a rotation axis. The operation is a rotation by 360 degree divided by n, where in this case n is equal to 2. The example they've given is p-chlorobenzene, and you can see that if you turned this chlorine atom over here by 180 degrees, it would end up in that position there. Okay, then we have the C3 symmetry operation, which means that we have again a rotation axis, and then that is rotation by 360 degrees divided by n, where n is equal to 3, so that is 120 degree rotation. You can see that there's one rotation here, 1, 2, and then this one at the back there like that. Okay, some more examples. C4. Again, the symmetry element and operation is the same as before. In this case, the rotation is a movement by 90 degrees. Okay, a C5 is the movement by 360 divided by 5. I'll leave it for you to work that out. And then finally C6, which is 360 divided by 6, which is 60-degree angles. So you have 6 of those. Okay, we have reflections with the symbol sigma. The symmetry element is a mirror plane. The reflection is through a mirror plane itself, and the examples given are those vertical mirror planes in water. The inversion center, we have the inversion point there where we have inversion through a center point. So in this case, we see the example of ferrocene. The inversion center would sit on the iron itself. And then the last one, obviously, summary that we're doing is rotation, reflection, or improper rotation, given the symbol S. And we know that for methane and staggered ethane with the examples that we've done previously, where we have rotation by 360 degrees divided by n, whatever n may be. In the case of methane, it's 4. So that would mean a 90-degree rotation, followed by reflection in the plane perpendicular to the rotation axis. Okay, so if this is the direction of the rotation axis along the red line I've just drawn, then the mirror plane would be, let me use a different color, I'll use green. The mirror plane would be perpendicular to the rotation axis. And that kind of summarizes everything we've done with symmetry operations and elements at this point. In part 4, we're going to go on to seeing that some molecules don't just have single symmetry elements, they have more than one, so they don't just have rotation axes, they have mirror planes, they have inversions, they have improper rotations, and we're going to look at how they are all grouped together.